Picture the following situation. P1. At the beginning of the race, Achilles is at point x0 and the tortoise is at point x1, where x0 is to the left of x1. So the tortoise has a head start. From now on, we only consider points that are to the right of x0 when we describe what is happening as time progresses, or, in any case, as it seems to progress. Our second premise is P2. When Achilles is at point x1, the tortoise is at point x2, where x1 is to the left of x2, and Achilles does not overtake the tortoise at any point between x0 and x1. This is certainly plausible. When Achilles reaches x1, the tortoise will have advanced a little bit in the meantime, and x2 is the point to which he has advanced. Similarly, when Achilles is at point x2, the tortoise is at point x3, where x2 is to the left of x3, and Achilles does not overtake the tortoise at any point between x1 and x2, and so on. Generally, for all n greater than or equal to 1, when Achilles is at xn, the tortoise is at xn plus 1, where xn is to the left of xn plus 1, and Achilles does not overtake the tortoise at any point between xn minus 1 and xn. Here the variable n denotes any of the numbers 1, 2, 3, and so on. Furthermore, we may assume P3. If P1 and P2 are the case, then Achilles does not overtake the tortoise at any of x1, x2, and so on, nor at any point in between any two of them. The ... in the premise simply means and so on. Premise 3 should be unproblematic, since if premises 1 and 2 are the case, then Achilles does not overtake the tortoise at x0, nor at any point between x0 and x1, nor at x1, nor at any point between x1 and x2, and so on. So far, so good. The underlying idea of the remaining premises of Zenos' argument is that Achilles will never be able to move beyond all of the points x0, x1, x2, and so on. No matter how long one is going to wait, Achilles will still be to the left of some of these points. And so, he will never overtake the tortoise, which is absurd. Let us state this more precisely now. First of all, this should be obvious again. P4. It takes Achilles a positive amount t0 of time to get from x0 to x1. And it takes Achilles a positive amount t1 of time to get from x1 to x2, and so on. Generally, for all n, it takes Achilles a positive amount tn of time to get from xn to xn plus 1. Here n denotes any of the numbers 0, 1, 2, and positive just means longer than nothing. Moreover, it certainly appears to be true that the periods of time that it takes Achilles to pass the various distances run by the tortoise add up to longer periods of time. So we have P5. If P4 is the case, then for all n, it takes Achilles the amount t0 plus t1 plus t2 plus and so on up to tn of time to get from x0 to xn plus 1, where each of t0, t1 and so on up to tn is a positive amount of time. But when one puts together infinitely many positive periods of time, they seem to become arbitrarily large, larger than any given finite amount of time. That is, P6. If for all n it takes Achilles the amount t0 plus and so on up to tn of time to get from x0 to xn plus 1, where each of t0 and so on up to tn is a positive amount of time, then the amount of time t0 plus t1 plus t2 plus and so on in which Achilles is to pass each of x0, x1, x2 and so on, is not bounded by any finite amount of time. Not bounded by any finite amount of time means the periods taken together get arbitrarily large. For any given amount, the sum exceeds that amount at some point along Achilles' way. Now, surely the following is the case too. P7. If the amount of time t0 plus t1 plus t2 plus and so on, in which Achilles is to pass each of x0, x1, x2 and so on, is not bounded by any finite amount of time, then Achilles never actually passes all of x0, x1, x2 and so on. And by the positions of the points x0, x1, x2 and so on, we also know P8. If Achilles never actually passes all of x0, x1, x2 and so on, then he is always somewhere to the left of at least one of x1, x2 and so on. Again, by looking at what the spatial situation is like, the following seems fine as well. P9. If Achilles does not overtake the tortoise at any of x1, x2 and so on, nor at any point in between either of them, and also he's always somewhere to the left of at least one of x1, x2 and so on, then Achilles never overtakes the tortoise. But now, by taking all of our premises together, we may logically conclude, conclusion, Achilles never overtakes the tortoise. This is because premises 1 to 3 give us that Achilles does not overtake the tortoise at any of x1, x2, nor at any point in between any two of them. And premises 4 to 8 give us that Achilles is always somewhere to the left of at least one of x1, x2 and so on. Taking these together with premise 9 entails the conclusion. Our common sense assumptions concerning apparent motion, supplemented by a little bit of reasoning, seem to justify the claim that Achilles never overtakes the tortoise. That is an absurd conclusion. In any case, it is in conflict with another of our common sense assumptions concerning apparent motion, that is, that Achilles should be able to overtake the tortoise in this hypothetical situation. So something has gone wrong. Since the logic of the argument is fine, one or several of the premises must actually be false. And this is what Zeno wants us to conclude. Our apparent experience of change is merely apparent. Really, there is no change, and hence no movement at all. The premises that are based on this illusion are false. And maybe our whole conception of change is incoherent.